that between 35% and 47.5% of the time, we're going to get hits. Are we 100% sure of that? Of course not. Of course not 100% sure. We can't be 100% sure. We could be wrong. How sure are we?
95%.
That's what you have. That's what the 95% comes in. I am 95% confident. Go, Ben. I'm 95% confident
that we could repeat the experiment and get a similar result.
Yeah, exactly. So the idea is somewhere on this number line is what you're looking for, which is P, not P hat. You're not looking for P hat. You can find P hat very quickly, right? You can find P hat very, very quickly. P is floating around on this number line somewhere, the actual true percentage of hits. You are saying, we are saying, we are 95% certain that it's between 35% and 47.5%. We don't know where it is in there, but we're 95% certain that it's in there. Which means we're 5%, we have to admit that 5% of the time, we're going to be wrong. Now, I've got a quiz coming for you guys in 2 weeks. I told you on the first day, you may have some mandatory quizzes every once in a while where I'm going to make you do a quiz. I got a great idea for a mandatory I'm going to have you guys do. That involves Excel doing something like this, where you actually calculate a bunch of intervals and you see if a parameter falls in or falls out and track how often. And we're going to see if we get that 95 to show up. Please, Allie.
Do the mandatory quizzes go towards our 10 or?
Yeah, they do. They're just like any other quiz, for sure, assessment-wise. So the idea when you say you're 95% certain, or you're 95% confident is, you admit that if you run this experiment 20 times, you admit that you're expecting in one of those 20, you're going to miss finding what you're trying to find. Does that make sense? 95% is 19 out of 20. So in 19 out of 20 of those trials, on average over time, you're going to capture what you're looking for, but you have to admit that on average over time, you're going to miss 1 in 20 times. Now here's the catch, right? Here's the catch. What if that is this time, right? What if this is the one that's egregiously wrong due to outlier data? What do? Dude, you replicate the study. You replicate it, right? That's why it was so important. Now, granted, this was fictitious, right, Chris, as you pointed out. Bit fictitious, because we used the same sample point and then built off of it. But exactly, but we have more repetitions here. But that's why you repeat, that's why you do repetitive studies, to see if you're more likely an outlier or if you're more likely the mode. Now, mathematically, you're more likely the mode. Mathematically, you're more likely the mode. But you don't know that with a sample size of 1 or with a study size of 1. You have to compare it over time to see. Yes, please.
So would that mean that 20 would be a number that you want to replicate?
Sample size, you want to replicate?
No, like the times.
Oh, the number of times. That would be great. The problem is finding the funding to do that.
Right, but that would be like the ideal.
That would be ideal. Would be the more the better, honestly. Ideal would be the more the better. And here's the thing. You can actually do it with far fewer than 95. Check this out if you don't mind. We're getting further away from Connor's question. I promise you I'll get to it. If you think about the idea of redundancy from 243, right? So we'll operate at 95%. Treat the interval itself as a binomial. 95% of the time you're going to capture your parameter, 5% of the time you're going to miss. So if you replicate, let's say replicate once or twice or 3 times or 4 times, blah, 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 blah. You see a pattern pretty soon. You know, what's the probability that they all miss? And when I say they all miss, that none of them come close to actually trapping the parameter you're looking for. Well, if you only do it once, well then it's a 5% chance. There's a 95% chance you hit it. There's a 5% chance you don't. What if you do 2 independent trials? What's the chance they both miss? Somebody just said it, I think. It's that. It's squared. Assuming it's independent, it becomes binomial. How about 3 times? How about 4 times? If you guys are heading in 243, this is the pumpkin seed experiment all over again. How many pumpkin seeds do you have to plant to make sure at least one of them catches a pumpkin and plants a pumpkin? We planted 36 or 40 seeds in our garden this year. We got a 75-pound monster. We also got a lot of flowers that didn't make pumpkins. But we redundantly planted a bunch of seeds knowing we'd have to plant a bunch to shrink this down as close to 0 as we wanted it to be. Fair? Back to that idea of binomial again. I love the math behind this, it's so much fun. Fair-ish. Getting there, maybe. So that's what the confidence is. And I got the quiz coming that'll hopefully drive home that, Aaron, it's been a question. It's been a question. Just process it, just take it all in. Good for you, good for you. Connor, let's answer your question and call it a day. I did have an in-class quiz. We'll start with that first thing on Thursday. Better that way, rather than let this wash over you. I'll put some extra resources on the schedule page for you guys to interpret this some more. I got some nice applets I found online that'll help, I think.